transformer. To transform means simply to change. Here, the limit is only AC. This instrument is designed and it functions with AC only, not with DC, because it is based on the principle of mutual induction and DC doesn't work with it. Transformer means you apply the alternating current, you get its current or its voltage changed. You see, voltage or current both might change, but in proportion that is going to be in reverse. Both can neither increase or decrease together. It works on the principle of mutual induction. It means you apply the AC to primary coil and you obtain the output from the secondary coil. On one iron frame, you are going to have two coils, and the frame, like rectangular frame, on which you just use two coils. One is primary, used for sending the initial current, and the other known as secondary, for obtaining the output current. Because the same iron frame is associated with both the coils, the rate of change of flux is going to be same. In primary, it's going to be minus Np d phi dt. In secondary, it's going to be Ns d phi dt. Listen again. I say here that flux associated with every turn of both the coils is going to be same, simply for the reason that frame is same. If you take the ratio of the two output and input, it's going to be Ns upon Np. You see, when you are taking the ratio of EMF, obviously it is going to be the ratio of the voltage, and the ratio of number of turns in both the coils this way is known as transformation ratio. So what you find here, the interesting aspect of this very relation is that if you increase the number of turns in secondary coil, you can increase the voltage output in secondary. That means the variation of voltage is going to depend entirely on the number of turns used in primary and secondary. And by using Ns greater, we are going to have a step up transformer in which the secondary voltage is going to be greater. That will be known as a step up transformer. And to show a step up, we'll have to use this kind of symbol in which the primary will be having thick and less number of turns, whereas secondary will be having taller coil. That means number of turns will be greater. This will be long and thin wire. This is a step up transformer. Similarly, in a step down, you'll have the reverse case. Secondary is going to have thick and short wire. Primary is going to have long and thin wire. But you see, this transformer is not going to work with any source of energy. Obviously, it has the limitation of giving you the same power. But that too is possible only when the transformer is ideal. Otherwise, there are some losses and the power output is going to be always less than the power input, because certainly some loss will occur whenever there is flow of current through any conductor. We are not going to have superconductor, that's our limit. So, efficiency is going to be output upon input, and that will obviously be less than 1, that is 100%. Now, this reduction in output is always accredited to these losses. These losses are copper loss, leak loss, or flux loss, you might say, and then iron loss. Copper loss means in the copper coil, both are copper coils, primary and secondary. In these coils, heat is produced because of eddy current. So, there is copper loss. Flux loss simply means that whatever the magnetic field is produced because of induction in both the coils, some of the magnetic lines leak through, and that amounts to flux loss. Then finally, there is iron loss. You see, the iron frame over which the coil has been adjusted, iron frame is subject to hysteresis. Because of hysteresis, there is always production of heat. So, that is one reason. And not only hysteresis, this iron frame will have the heat production because of eddy current also. These are the factors responsible for reduction in power output through the transformer. But you must compare this transformer with amplifier. Here it will be noteworthy to put the name of amplifier, which is capable of increasing power also. You see, transformer will increase the voltage, decrease the current at the same time in the same inverse proportion. But this is quite possible with amplifier that we will study in electronics, which can increase the voltage, current and power together.